mean it. I'm pretty sure I know more about him than his cat. So obviously, when he drops a song, I need to know it first. इसलिए I follow Spotify's release radar playlist, which keeps me updated all the time. By the way, he used the word violet like 4 times this year. Pakka means something.
Get the latest music from your favorites with Spotify's Release Radar playlist. Explore now.
It's
क्या
that time
है
of year again. Spotify Wrapped season is
फर्जी
here.
पानी थी
Wrapped is a celebration of the music and podcasts that made your 2025. And this year, it's answering all the important questions like what genres defined your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped for more stories and even more surprises. Happy Wrapped!
पता था, मुझे पता था. अरे यार.
Ah, it's that time of year again. Spotify Wrapped season is here. Wrapped is a celebration of the music and podcast that made your 2025. And this year, it's answering all the important questions like what genres define your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped for more stories and even more surprises. Happy Wrapped!
अबे यार.
Ah, it's that time of year again. Spotify Wrapped season is here. Wrapped is a celebration of the music and podcast that made your 2025. And this year, it's answering all the important questions like what genres defined your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped for more stories and even more surprises. Happy Wrapped!
अरे यार इसके नाम मतलब. तोड़. फैनविक ट्री से इन्हें आ रहा है तो मुझे देखना है कितने मेरे से बड़े हैं उतना ऐड हो जाएंगे. जब ये रिमूव हो रहा है तो मुझे रिमूव करना है. रिमूव तो राइट में सारे कितने मेरे से छोटे हैं. फैनविक ट्री पास कोऑर्डिनेट कंप्रेशन पहले कोऑर्डिनेट कंप्रेशन कर दो. फैनविक ट्री कहाँ है? फ्रीक्वेंसी मतलब सम ये है ना. सम है एंड चाहिए है.
It's that time of year again. Spotify Wrapped season is here. Wrapped is a celebration of the music and podcast that made your 2025. And this year, it's answering all the important questions like what genres define your year? Which artist took your number one spot? And which club do you belong to based on your listening? Open your 2025 Wrapped for more stories and even more surprises. Happy Wrapped!
इतना टाइम क्यों लगा? लगना नहीं चाहिए। Chat rank है। ये क्या है? What is this? Oh, I don't think. Okay, so I'm going to try to explain today's what's this Biweekly 171. This was an easier contest, although my performance was abysmal dog shit because of silly mistakes, but still the problems were fairly straightforward. Dog order implementation, but Q1 was basically you had to do what was stated. Like you have basically you can write a function to check if the number is prime or not, since the constraints for the number are up to 10 power 9. Yeah, the constraints are up to 10 power 9, so you can write this loop which runs in O of root n to tell whether a number is prime or not. Be sure to add this line because like I always forget to add this and it led to the wrong answer, but outside of that you can check for the prefix and suffix separately. You can create a running prefix by multiplying the current value into 10 and then adding the current digit. So like if for example for this prefix, let's say 7, if we have 1 2 3, to make it 1 2 3 7, we multiply 1 2 3 by 10 and then add 7, right? So you can just do that, and for every x check if it's a prime, if not return false, and at the end return true. For the suffix, since we want to go this way, instead of multiplying into 10 and adding the digit, we add the digit multiplied by the power of 10 itself. So we go from here, assume we have 37, so to 37 we add 37 plus 2 raised to the power how many places we have gone this way, so 2 raised to the power 2 into 10 raised to power 2, since this is the hundreds place, right? So that was Q1. Q2 okay, so Q2 is basically, this was another straightforward like implementation problem only, which I messed up. 16 minutes, there was no reason for this to take 16 minutes, but basically the operation is fairly atomic. You can add 1 or decrement 1 to any number, and we need to make it a binary palindrome. So palindrome is like it reads the same way forward, and this is a 3. It reads the same way forward and backwards, and a binary palindrome is the same thing, but all the numbers have to be a bits. So this number, okay, whatever this number is a binary palindrome. 0 is not there, the numbers start from 1. 0 would be a binary palindrome if it were considered here, but the constraints are for the constraints were fairly important here. The thing is, since the numbers themselves are till 5000, what we can do is we can run a loop to pre-compute if first we can check if a number is binary palindrome or not. Since the constraints are fairly low, we can do this, else we would have to do some, like for palindromes you can use this trick, like you can only iterate on the left half and then you can mirror and add the right half, but that's not required yet since the constraints were fairly small. Like if this was, let's say 10 power 9 or something, what we would do is, would that work? Nah, I don't think that would work since it's a scrap that idea. Whatever. So basically here what we do is we can iterate on every number till the max number into limit. I just took an arbitrary higher limit because there is a chance that 5000 is not a binary palindrome, but there could be a number next to it which is a binary palindrome, which is very close. So I just took a fairly large limit which I knew would work within the constraints. I basically run a loop for every number. If it's a binary palindrome, I push it into this vector. Now my objective was I wanted a dpx where dpx would tell me the minimum number of steps so that x can be made into a binary palindrome. So for that, since I already have this, I already have all my binary palindromes in this bpals and they are sorted since I have put them in the ascending order. I can binary search on the value which is just less than equal by previous of upper bound and the value which is just greater than equal, and then I can do this. I hope this is visible. Then I can do this r minus I minus l to get min and then store it in this, and then I can basically just pre-compute this for every test case, which is why my runtime was fairly fast. Yeah, 7 milliseconds. I would assume this is like if they showed the thing, it would be fast here. And then, am I audible? बाद में देखा जाएगा. And then just you can, after pre-computing, just create a result vector and then set the values here based on the DP numSci. Here the mistake, the reason it took me this long, yeah, it would be visible in the screencast, is I was doing this instead. So like, wow, just keep your eyes open while doing stuff, I guess. This was a like fairly straightforward greedy problem. Like my initial idea was, okay, obviously you want to maximize your points, so that's the first thing. And the second is we have to choose at least k, right? Yeah, we have to choose at least k from the first vector, tech1 vector. So like you would think, okay, just sort based on, you can use this as a key to sort and take the largest ones. But the thing is, what if, like always for greedy problems like this, try to make cases like very skewed cases. Like for here, you could take a very large, 1 second, oh my god, scuffed presentation here. You could take a large vector and then you could, like, this is tech1, right? Assume these are sorted like this. Since we have sorted based on tech1 and now we have tech2s, for this you would say that, okay, I'm taking the largest tech1, but it is highly possible that we have a tech2 which is very large for this, and here like this is larger than all of the values combined. So here choosing this would be the obvious one if we had to choose, let's say, less than n here. So what we can do here is, like, if we write some equation here, like basically we want to maximize us. So if we write a loss equation, the loss would be, if for some I, the loss would be tech1 I, I'm using a mouse so do forgive my handwriting, minus tech2 I. This would be a loss, like if we were choosing tech1 instead of tech2. Now if tech1 is greater than tech2, then it's good, so loss would be positive. So it wouldn't be loss, like this is some function f of I, not loss. F of I higher is good because that means our choice was good. F of I low is bad because that means we are basically losing the thing, right? We are choosing tech1 when it is low, so this number becomes negative. If this is very small and this is very high, the function will become negative, right? So we can sort based on this key instead and then choose the k largest ones, and then for the remaining we would just take the maximum, since otherwise we can choose either of them. It can be completed using either technique, so we can just do max tech1 tech2. So I sorted based on this, only this function tech1 tech2 tech1j tech2j. I sorted based on this. Since I sorted like this greater, so the largest f of i's would be at the front, I'll take them, and then the remaining I'll just do max. And this is the fourth problem. This was fairly standard. This is actually like 1:1, like they ripped this problem off. CSES, where is it? Sliding window. This problem, sliding window inversions. This is like you are given an array of n integers, you have to calculate the number of inversions in each window of k elements from left to right. So here, instead of for finding for every window, like we had to do the same thing and just minimize across all windows. So here the answer would be 0 since we are minimizing it. So I just applied this technique here. Inversions are in of themselves a standard problem. An inversion basically is like, if it's defined in the problem, and if you are reading this, watching this, you probably might know, but like for some let's say array ai greater than aj provided I is less than j. This basically means, like, if in a normal case, non-descending case, array is like 1 2 2 3 5, like this, right? But if there's any fall, that would be an inversion. So if here 2 comes, 2 is an inversion with respect to this and with respect to this, because it is ahead of them and it is smaller than them. So for counting this, for counting inversions, there's a standard technique. You either use a PBDS or use a Fenwick tree. I use a Fenwick tree here because PBDS can be risky when using values which are equal to as well. But so for the standard technique for inversion counting using Fenwick tree is, first you have to compress the values to a range where you can build build a frequency array on that range. Here we can have at most 1e5 values, right? Even though values are till 1e9, they would, if if they were large, we can compress them till this range. Since at max we can have 1 distinct values. So after compressing, we make a assume a frequency array we make for those values. This is the frequency array we make after compressing the values. And since this is a sliding window, we can easily model our function like we are adding an element and we are removing an element. So assume, should I make an example? Wait, 1 second. Let this be an example, right? So and the window size is 4. So I am, let's say I'm here right now. So my frequency array would be 1, 1, 1 and 1. So now what I'm doing is first, and let's say somehow I have the count of inversions in this. So what would the inversion count here? For 3 we have 2 and 1 as inversion. For 2 we have 1. No, I'm doing it in the reverse order. So for 2 we have 3, for 1 we have 2 and 3, and for 4 we have nothing. So we have 3 inversions. So now what we are doing is we first have to remove this element from our window. So the contribution of this element would be the number of elements to its right, which are less than this, right? And we would already know all elements to my right, basically all elements in the window aside from this 3 itself are to my right, because this is the last element of a window. This is going to be excluded, right? So I basically need to know the count of elements less than 3 or less than equal to 2. So I can just get this thing, the sum of this, and then that would be the contribution of this. So once this is removed, the number of inversions go from 3 minus 2, so become 1. And if I move this window, my bad, 1, 3, 2, 1, 4, 5, 1, slide this one step right, and here we can see that in fact there is only one inversion which is 1, 2. Now what we have to do is we have to incorporate 5 as well. Now if we apply the same logic here, all elements, the contribution here would be all elements to my left which are greater than 5. Technically, since we are just adding 5 here, all the elements in my frequency array would be to my left, right? Since 5 is just being introduced here. So we basically just need to get the count of all elements, the count of the frequencies which are greater than 5, or we could do less than equal to 5 and then subtract from total, which is what I did here. Here this is a bad example. So we can see the contribution here would be, we do this 4 and then we do 0, right? Because the number of elements less than equal to 5 are 4, and then the size of the array itself is 4. So 4 minus 4 is 0. So this will provide 0 contributions, which does track since this subarray has only one inversion. And you could do the same thing with the PBDS as well, or a sorted list equivalent in Python. I guess this would be clear. Just try this problem, and if not this, somebody must have made an editorial for this, so you could refer to this. My implementation was this only. This is my Biweekly template. So first you compress the values. First you initialize, since we want to minimize here, you initialize to an arbitrary infinity. Compress the values. I used 0 as a flag just in case. If now I have m distinct elements in my map, so frequency array, Biweekly. Biweekly basically allows you to run prefix queries in log n, like prefix sum or whatever prefix. Max also works in some cases. So now I is my left pointer, j is my right pointer. If my window size is greater than k, I basically y is my actual value, right? Since I have compressed this, so I have to get the compressed value here. I get the count less, and then I remove the contribution, which is the thing I did here. And then I move I ahead as well, and then frequency array, I decrement the value because it is no longer there. Similarly, introduce x here. I made a silly typo here, I instead of j. Count less than equal, and then I do the window size minus count less equal, which is the thing I showed here. And then if the size is equal to k, only then minimize. For some reason the runtime is fairly slow here. This shouldn't be this slow. What is this? 725 milliseconds is way slower than expected. Since the CSCS problem only, it gave me 26 milliseconds, 260 milliseconds, that too with a PBDS. Yeah, the implementation was smaller here, should have done this only, but that too with a PBDS, and PBDS is slower than Biweekly from. Okay, must be some, I guess. Am I printing something? Nope. Curious. I will see. Alright, so this was the scuffed editorial. It was mostly, the problems were fairly straightforward, so like there's nothing to explore here. Alright, why is unfortunate? Never mind, I'll see you, I guess. Bye.